Chapter 22, Heat Transfer, Section 1. The spontaneous transfer of heat is always from warmer objects to cooler objects. If several objects near one another have different temperatures, then those that are warm become cooler, and those that are cool become warmer, until all have a common temperature. This equalization of temperatures is brought about in three ways: by conduction, by convection, and by radiation. Section 1. Conduction. If you hold one end of an iron rod in a flame, before long the rod will become too hot to hold. Heat has transferred through the metal by conduction. Conduction of heat can take place within materials and between different materials that are in direct contact. Materials that conduct heat well are known as heat conductors. Metals are the best conductors. Among the common metals, silver is the most conductive, followed by copper, aluminum, and iron. Conduction is explained by collisions between atoms or molecules and the actions of loosely bound electrons. In the iron rod, the flame causes the atoms at the heated end to vibrate more rapidly. These atoms vibrate against neighboring atoms, which in turn do the same. More importantly, free electrons that can drift through the metal are made to jostle and transfer energy by colliding with atoms and other free electrons within the rod. Materials composed of atoms with loose outer electrons are good conductors of heat, and electricity also. Because metals have the loosest outer electrons, they are the best conductors of heat and electricity. Touch a piece of metal and a piece of wood in your immediate vicinity. Which one feels colder? Which one is really colder? Your answers should be different. If the materials are in the same vicinity, that means they're in the same place. They should have the same temperature, room temperature. Thus, neither is really colder, yet the metal feels colder because it is a better conductor. Heat easily moves out of your warmer hand into the cooler metal. Wood, on the other hand, is a poor conductor. It's a good insulator. Little heat moves out of your hand into the wood, so your hand does not sense that it is touching something cooler. Wood, wool, straw, paper, cork, and polystyrene, which is styrofoam, they're all poor heat conductors. Instead, they are called good insulators because they delay the transfer of heat. A poor conductor is a good insulator. Liquids and gases in general are good insulators. Air is a mixture of gases and conducts heat very poorly. Air is a very good insulator. Porous materials having many small air spaces are good insulators. The good insulating properties of materials such as wood, fur, and feathers are largely due to the air spaces they contain. Birds vary their insulation by fluffing their feathers to create air spaces. Be glad that air is a poor conductor, for if it were not, you'd feel quite chilly, even on a day that was 77 degrees Fahrenheit. Snowflakes imprison a lot of air in their crystals and are good insulators. Snow slows the escape of heat from Earth's surface, shields Eskimo dwellings from the cold, and provides protection from the cold to animals on cold winter nights. Snow, like any blanket, is not a source of heat. It simply prevents heat from escaping too rapidly. Heat is energy, and it is tangible. Cold is not. Cold is simply the absence of heat. Strictly speaking, there is no cold that passes through a conductor or an insulator. Only heat is transferred. We don't insulate a home to keep the cold out. We insulate to keep the heat in. If the whole home becomes colder, it is because heat flows out of the home. It is important to note that no insulator can totally prevent heat from getting through it. An insulator just reduces the rate at which heat penetrates. Even the best insulated warm homes in winter will gradually cool. Insulation delays the heat transfer. Let's look at the picture, figure 22.4. It shows a bunch of houses. A lot of them have snow on their roofs. Some of them don't have snow. Let's read the caption below the picture. It says, "Snow lasts longest on the roof of a well-insulated house. Thus the snow patterns reveal the conduction or lack of conduction of heat through the roof. Can you see how the insulation of these houses vary?" So the ones that have poor insulation let heat flow out and melt the snow, and there's no snow on the roof. If they are well insulated, then heat doesn't leak out of the house and it doesn't melt the snow, and the snow remains on the roof. Pretty cool, huh? Okay, we're almost done with this section. There are 3 questions. I'm going to read each one, pause a little bit to let you think of an answer, and then I'll tell you the answer the way I think about it. Question number 1. If you hold one end of a metal bar against a piece of ice, the end of your hand will soon become cold. Does cold flow from the ice to your hand? The answer is no. Cold does not flow. Energy flows. It doesn't flow from the ice to your hand. It flows from your warm hand into the colder ice. Number 2. Wood is a better insulator than glass, yet fiberglass is commonly used to insulate wooden buildings. Why? Well, you may not know this, but fiberglass is that pink, fluffy stuff that looks kind of like wool, but it's pink, and they lay it down in walls and in the attic of your house. It's made out of small fibers of glass, which is not a very good insulator. Why do they use it to insulate wooden buildings? The answer is because that fiberglass is fluffy and it traps a lot of air in between the glass fibers, and the air is what provides the good insulation. Number 3. You can stick your hand into a hot pizza oven for several seconds without harm, whereas you'd never touch the metal inside surfaces of the oven even for a second. Why is that? The answer is that if you stick your hand into the oven but you don't touch any of the hot metal parts, heat doesn't flow into your hand very quickly. Your hand is surrounded by air, but air is a good insulator, so the heat doesn't flow into your hand too quickly and your hand doesn't burn, at least for several seconds. But if you touch metal, then the metal quickly flows into your hand gets very hot and gets burned very, very quickly, almost instantly.